Welcome to another informative episode of AWS Solution Architect Associate Exam Question Series on Exam Tricks and Tips channel. Please like, share, and subscribe to get regular updates on new episode releases.
Welcome to episode 7 of Associate Solution Architect series. We'll cover question 31 to 35 in this episode. For questions 1 to 30, please refer to previous episodes of this series. Let's get started. Question number 31. Within a month of being bought, a newly acquired firm is needed to establish its own infrastructure on AWS and transfer various apps to the cloud. Each application requires transmission of around 50 terabytes of data. Following the transfer, this firm and its parent company will need to secure connection with constant throughput between its data center and apps. A solution architect must guarantee that data transfer occurs just once and that network connection is maintained. Which solution will satisfy these criteria? Let's look at the keywords here. We need to transfer various apps to the cloud. We have about 50 terabytes of data, so that's a lot of data. Following the transfer, we need secure connection for this particular activity, and data transfer occurs just once, and we need to maintain the network connection. Now, if you see, there are 4 options here, and 2 of the options has VPN. VPN is not going to be reliable. VPNs are generally slower, have lower throughput as compared to the options like Direct Connect that we have here. So according to me, anything that is involving VPN will not be a good idea. The requirements, we need secure network connection, which is fine from VPN perspective, but we need to maintain the network connection. So we need good bandwidth and reliable connection between on-prem network as well as AWS. So that helps us rule out few options here. So option B, which is having site-to-site VPN, and option D, which has site-to-site VPN for ongoing connectivity. I think we can safely rule those out. They are not the right options based on what we have here. So that makes the job easy. Now we have 2 options left. So first option A includes AWS Direct Connect, and it is used for both initial transfer and ongoing connectivity, whereas option C has AWS Snowball for initial transfer and AWS for Direct Connect ongoing connectivity. According to me, using Direct Connect for both initial transfer and or ongoing connectivity would be unnecessarily complex. I believe setup time for Direct Connect is going to be much more higher. Plus, we have 50 terabytes of data. So I guess from an initial transfer, my preferred solution would be Snowball. Snowball is used for petabyte scale transfer, and this particular data size would be an ideal choice to do initial transfer through Snowball. So that's an excellent choice. And for ongoing connectivity, we can have AWS Direct Connect, which then would have a maintained connectivity from on-prem network to AWS premises with a secure and a maintained connection. So I would go for C. That's my answer. So I'll rule out option A. Because I don't think we need Direct Connect for initial transfer as well as ongoing connectivity. C Snowball and Direct Connect, I think that's a good choice for using Snowball for initial transfer and Direct Connect for ongoing connectivity. So answer for this particular question is option C, Snowball and Direct Connect combination. Question number 32. A business does not currently have any file sharing services. A new project needs file storage that can be mounted as a disk for on-premises desktop computers. Before users can access the storage, the file server must authenticate them against an Active Directory domain. Which service enables Active Directory users to deploy storage on their workstation as a drive? So what do we have here in terms of problem scenario? This is another on-prem to AWS question, similar to what we saw in the previous question, but instead of a network activity here, we are talking about more about a storage solution. There are some options which are related to network as well, but mainly it's on-prem to AWS file storage solution with the combination of Active Directory access. So we have certain users in on-prem. We want to mount their workstation with as a drive onto AWS storages, and we are looking for some solution over here. Now, if you look at the option A says Amazon S3 Glacier, and we know Glacier is basically a archival solution. So if you need any long-term archival storage, that is when you use Amazon S3 Glacier. It's not a solution for mounting disk drives for individual users. So that's an obvious wrong for me. So we rule that out. Now the second one from this list, which is not correct for me, is AWS Data Sync. If you know Data Sync service, it's a service that transfers data between on-prem storage and AWS storage from a migration perspective, or if on a regular basis, if you want to keep the data sync between both the storages, you have a storage in on-prem and you have storage in AWS. For that purpose, it doesn't have actual storage. It's a service for maintaining or syncing the storage. It doesn't provide actual storage. So it's a wrong option in this particular scenario. And then that leaves us two options, AWS Snowball Edge, option C, and AWS Storage Gateway. Snowball is essentially an appliance that can help you transfer petabyte scale data from on-prem to AWS. So if you need, and typically it's used in migration or maybe moving backups if you don't have a good network connectivity. It's a device that can be shipped to customer premises. Customer copies the data that is shipped using courier to AWS, then AWS copies that data into the storage that is available at AWS or chosen at AWS. Now, this is not going to be used where you want to integrate it directly with Active Directory. So it's not the correct solution here. The second requirement around Active Directory is a key one. And that leaves us, the last option on this question, which is option D, AWS Storage Gateway. Now, you know how AWS Storage Gateway works. If you want to extend your on-prem storage capacity, you can use Storage Gateway, which generally points to S3, and you have virtually infinite storage in AWS through the Storage Gateway. But what there is another feature of Storage Gateway is that it directly integrates with the Active Directory service as well, which will allow desktop users to authenticate using Active Directory and map the storage that is available through this arrangement as drive. So this is a perfect solution. We go for this. Our answer is option D, AWS Storage Gateway. And if you want to just look at this option carefully in terms of what it gives us. So it acts as a file gateway. This gateway presents an SMB file share to on-premises client. It can join an Active Directory domain and authenticate users against it. Users can then mount the file gateway, share as network drive. It can also serve as a FSx file gateway. This gateway integrates Amazon FSx for Lustre, a high-performance file system. It also supports Active Directory integration and allows mounting the FSx file system as a local drive. If you have Windows operating system, you can use FSx file gateway. So that's an overall, analysis of that option. I also have some documentation from AWS around how storage gateway can be combined with Active Directory for authentication of the users, and you'll find a link for this in video description. You can go through this documentation and understand a bit more about how AWS Active Directory is used with storage gateway for authentication of users. That's it on this question. We'll move on to next question. Amazon DynamoDB is being used by an entertainment firm to store media and metadata. The application requires extensive reading and often encounters delays. The organization lacks the people necessary to manage extra operational expenses and requires an increase in DynamoDB's performance efficiency without changing the application. What solution architecture approach should be recommended to satisfy this requirement? This is a database question, and this is around a key exam tip or a thumb rule that you should remember. Let's jump into the solution discussion. So what problem we have here is an entertainment firm like, say, Amazon Prime Video or maybe Netflix or some other entertainment firm is using Amazon DynamoDB. They're storing media data, media metadata in DynamoDB, which is basically data about data. In case of, say, movies, it would be about how long the movie is, who's acting in it, what's the genre of the movie, etc., etc. And there are extensive reads happening, and because there are a lot of reads happening, there are delays because of extensive reads. And organization wants to minimize the operational overhead. They do not want manual effort to make this performance better, and they don't want to also change the application. So that means we have to keep DynamoDB in the equation because we don't want to change the application. Now, whenever you have reads happening on data that is not changing quite often, and you want to improve the performance of such a solution, what you need to do is you need to use caching. What does caching do is you put caching ahead of DynamoDB, and that caching will make sure that anything that is frequently read is stored in the cache. And if you request the same thing again, instead of going to the database, it will be fetched from the cache. If you request a new item, then it will go to database because it's not available in the cache, but then it will cache it if that's getting frequently read. So anything that is frequently read, if you have reads which are repeated reads for similar sort of data, your solution is going to be caching, and that's your exam tip. Now let's look at what options have caching. So we can see multiple options where caching is available. We have option A, which is using Elastic Cache for Redis, and we also have option B, which is using DynamoDB Accelerator, which is a DAX cache. Let's try to eliminate some obvious wrong options, and then we will get to our correct answer based on the concept we have just discussed. So first one, obviously wrong for me, is option C, replicating data by using Dynamo global tables. Now, we said that we don't want to do any major changes here, and This is primarily intended for replicating data across regions. So if you have multi-region application and you want to keep your data in both the regions, then you can replicate global tables. This is not going to improve anything to do with read performance. So that's wrong. So let's rule that out. Then in the list, what we have. So option A is a cache option. It will cache the data, but it's not for DynamoDB. We have a solution in case of DynamoDB, which is called DAX, which is an option B, which is the perfect solution that AWS has created in case of DynamoDB caching. Uh, Elastic Cache may work, but it's generally used with RDS. So we don't want to change a lot in the application. We also don't want management overhead. So we have a better option available. So option A is ruled out for that. Option D, it says use of Amazon Elastic Cache for Memcache with auto discovery enabled. Now, Memcache might not be optimal for complex data structure like JSON used for media and metadata. Generally, when you talk about media metadata, it's stored in a JSON format, and auto discovery also adds complexity, potentially conflicting with desire for minimal changes. So option D is not going to be an ideal solution, first of all, and even if you implement it, it is going to take a lot of changes, and we don't want to do a lot of changes. And we do have an option, as we have discussed. We have a cache that is available in case of DynamoDB, which is called DynamoDB Accelerator, DAX. And that's the perfect solution in this case. That's the correct answer. If you want to understand this option in detail, what it gives us is, first of all, it gives us targeted performance improvement. So DAX is specifically designed as a fully managed in-memory cache for DynamoDB. So it's a solution that AWS has created for this specific use case. And whenever AWS has created a solution or a service for a specific purpose, you should ideally use that rather than try to create solutions from other services, which is going to be requiring operational overhead or a lot more changes. It significantly boosts read speeds with minimal latency and directly addressing the currently whatever has been advertised as the application problem, which is delays in read. In terms of then another aspect of this particular solution, operational overhead, DAX is fully managed service. So always use fully managed service whenever you want to minimize operational overhead. So this is a fully managed service. So no more operational intervention needed. And the last one, cost efficiency. DAX offers transparent pricing based on the provisioning capacity and allows for cost optimization based on its usage. Plus, by minimizing the reads going to the database, DynamoDB database is going to take load off DynamoDB, and caching is going to do that heavy lifting. So that is also going to bring cost efficiency in overall solution. Before moving on to the next question, if you're finding this analysis and discussion useful, then please hit that subscribe button if you're not already done it. Thank you. Question number 34. A business is using a tape backup system to offshore store critical application data. Daily data volume is in the neighborhood of 50 terabytes. For regulatory requirement, the firm must maintain backups for 7 years. Backups are infrequently viewed, and a week's notice is normally required before restoring a backup. The organization is now investigating a cloud-based solution in order to cut storage expenses and operational load associated with the tape management. Additionally, the organization wants to ensure that the move from the tape backups to the cloud is as seamless as possible. Which storage option is the cheapest? What do we have here in terms of problem description? We need to store backups on AWS cloud, and we need to maintain backups for 7 years, and it's infrequently used. So that's the overall problem description. The backups go to AWS. Now I've just put boxes here because we need to figure out a solution for this. And we need something in the middle from on-premises tape backups to be moved to AWS. And we need to figure out a technology at the AWS end as well, which will store tape backups. This particular question is about storage. So let's look at what are the storage classes. And I'm not going to go into detail of each of this, but as you can see from left to right, the cost keeps reducing. So S3 standard is the costliest one because the access time is millisecond and it stores it in 3 AZs, etc., etc. Whereas if you go to Glacier Deep Archive, then the cost is minimal. Obviously, you have an issue around the retrieval time is in hours as opposed to milliseconds in the case of S3. But if you then match it with our requirement needs cheapest solution. So S3 Glacier Deep Archive fits the bill. It also doesn't need to be frequently viewed. It's an infrequent access requirement. So that also complies. We need to maintain backup for 7 years, much longer duration. And that's what the Glacier Deep Archive is for. So I think from a storage perspective, I think Glacier is the right answer. But then we also need to figure out how you're going to map the on-prem tape backups to storage. And you already know that you can use a storage gateway, which then points to S3, in this case, S3 Glacier Deep Archive. which can then give you the complete solution. However, we need to figure out the nuances of what type of storage gateway it will be, which we can then choose from the options available. I would like you to look at this the article from AWS documentation, and this will tell you that AWS Storage Gateway Service integrates Tape Gateway with Amazon S3 Glacier Deep Archive storage class. And that's exactly what our problem definition is. We need to move some tapes from on-prem to AWS in cost-effective way, seamlessly, and we need it for infrequent access, and it has to be a cheapest option available. So I think our answer is going to be Tape Gateway. The destination storage in S3 will be Amazon S3 Glacier Deep Archive. Let's see whether we have these options available or not. That's how our solution will look like. You have your on-prem on the left side with Tape Gateways backups. Then you will use your AWS Storage Gateway to connect on-prem to AWS. You have this direct connect Amazon VPCs, which is kind of for completing the solution, but just focus on storage gateway and the storage aspect of AWS. And the data is going to be stored in Amazon Glacier. And that's your complete solution. Let's figure out, first of all, do we have our solution that we have just created? In the given options, do we have our answer? Yes, option A is available. That's the possible solution that we have created. Let's see why other options are not accurate. So option B, use Snowball Edge to directly integrate the backups with Amazon S3 Glacier. Now, you know how Snowball Edge is used. I don't think direct integration of S3 Glacier might not provide the same level of automation in this case as ease of use using a storage gateway. The way Snowball works is it's a physical appliance. You need to ship it. You need to copy this tape gateways onto Snowball and then move courier it to AWS location. It's not going to work. It's not the ideal choice. Second option is option C. It says copy the backup data to Amazon S3 and create a lifecycle policy to move data to Amazon S3 Glacier. You do not need to use S3 in this case. S3 is just going to increase the cost and overhead of moving tapes to S3. I don't think this is a correct option because we want to optimize the cost. We want the cheapest solution possible. We know from an on-prem to AWS perspective, we do have an option where you use storage gateway and directly move the data to S3 Glacier. There is no need to have S3 in between. So option C is wrong. And option D, again, it's probably the worst option. It uses option A and option C, and it's creating a new one. So option D basically says use storage gateway, then put data into S3, and then use lifecycle policy to move data back up to Amazon S3 Glacier. Again, it's absolutely not required. You do not need to use S3 as a middle service before you actually move data to S3 Glacier. You can use Amazon Storage Gateway straight away to integrate with Amazon S3 Glacier and move data directly there. And that's the perfect solution in this particular case. So our answer is option A, use Amazon Storage Gateway and integrate it with Amazon Glacier Deep Archive and move data directly over there. Perfect choice in this particular case. Question 35, a business's data warehouse is powered by Amazon Redshift. The firm wants to assure the long-term viability of its data in the event of component failure. What recommendation should a solution architect make? So the problem scenario here is a business is having a data warehouse in AWS. It's Amazon Redshift, which is a very powerful data warehousing tool. And they want to assure the long-term viability of this data in the event of component failure. So if a component fails, they want to make sure that the solution is overall reliable. So this is a reliability question, and anything that is about performance, we don't need as an answer. And if it's a reliability question, I would like to increase the instances of Redshift availability zone or regions, etc. So let's look at the options and select the best one. So first one, option A, is enable concurrency scaling. Now, as I just discussed, we need a reliability solution and we don't need a performance solution. If you enable concurrent scaling, that's going to improve the performance, and that's not what we need to solve here. We need to solve reliability aspects. So option A goes out for that. There is another invalid option. Option C says, let's increase the data retention period. If you increase the data retention period, what you're going to get you're going to get access to historical data for longer. This doesn't do anything in case of failure. So option C is obviously wrong. Then that leaves us with two options which are related to reliability. So option B says enable cross-region snapshots, and option D talks about deploying Amazon Redshift in multi-AZ. Now, if you look at option B, in case the failure happens, what will happen is you can get protection against region failure. So if you have your solution deployed in say region A, and if there is a failure there and you also have solution deployed in region B, you will this will be a good solution in that case. But in case there is a failure within the region itself, and that's what is asking about, that what if a component fails of a solution, then this is not going to work. So the correct answer will be deploying Amazon Redshift in multi-AZ. So you are essentially increasing the reliability of the solution by deploying Amazon Redshift multiple availability zones, and that gives you protection from a component failure within the zone. So I think that's the correct answer. Option B is incorrect because that's not an ideal solution. It doesn't protect you against a component failure. And option D is the perfect choice in this case based on what requirement we have been presented. And that's our correct answer for question number 35. Option D, deploy Amazon Redshift in multi-AZ environment. I believe this is the last question of this particular episode. I'll see you in the next episode of this series soon. Thank you.
This is Exam Tricks and Tips. You're watching AWS Solution Architect Associate Question Series. See you in the next episode. Thanks for watching.